This was a hackathon project which was evolved, and we'll see what we can do to decentralize web archiving. So IPFS is a content-addressable file system, right? It doesn't care about the location. As long as the content is same, the hash it generates is going to be the same. And as long as you have the hash, no matter where the file is in the network, it can be retrieved. So going back to HTML pages, on our left there is a simple HTML page. And if you try to archive that, archiving this means taking a screenshot. We don't want to do that. What developers write is the source code, which is on our right-hand side. But we don't want to archive that either. That basically means using browser's Save Page Now feature, which is bad. So what browsers actually get from the server, or what any client actually get from the server, is the whole HTTP response that has not only the HTML code that we saw, the payload, but extra HTTP headers. We want to archive this whole thing so that we can recreate the experience next time in future. So we want to save this. We can save it in individual files, but that will yield a lot of files, name collisions, and so many other problems. So we put it in a file format called WARC. And the whole payload and HTTP headers, on top of that, we put some extra WARC headers. And this whole thing makes a WARC record. Then in a single file, we can have 1, 200, or thousands and thousands of these records in a single file. Browsers don't support it by default. They should, but they are busy doing some other interesting things like web packaging. They could have just supported WARC files and you drop it and replay it, but they don't do it. So here is how Internet Archive's Wayback machine works, or any other Wayback machine generally works, basically. You got a WARC file that has hundreds of records in it. You index it, and the index generates references like which URL was archived at what time, and in which WARC file its content is preserved, at what offset, and how many bytes. So they create that index. In future, when people try to find that record, the index is used for lookup, and from there, references are retrieved, and the file content is retrieved from the big WARC file, and that's how it is replayed. So I'll also talk about Memento, which is a protocol that adds time dimension to the web. Basically, what it allows, you have an original URI, and you have historical versions of that URI. So you can time negotiate. Basically, you say, I want a version of this page as it appeared 2 years ago. And it will give you one of those URIMs, basically, on the left-hand side. Sorry, right-hand side. So this is a protocol that is being used in web archives extensively, well supported. This is another thing that browsers don't support by default. They should. So why IPWB? It is basically combination of IPFS and Wayback Machine. Problems in current web archives is the persistence depend on the organizations that are archiving them. If they are gone out of business, the archival content is gone. Availability of data is subject to censorship. Basically, Internet Archive is blocked in many countries like China, Russia. There are many URLs that generate the same content again and again, and these archives might have duplicates. They do something about deduplication, but not very effective. Not many people can archive. Now, some archives allow you to save your content there, but not every archive, and it's not very easy, not very popular. Although small archives exist, they're not discoverable. Not many people know anything but Internet Archive, so that's a problem as well. So how we do it, basically? So first, we take a web page or a set of web pages and create WARC files from that using tools like WARC create. There is wget allows you to doing that. There are tools like Heritrix full-fledged crawlers, you can generate WARC files from that. Once you have WARC file, you try to identify the HTTP header and payload, those blocks, identify them and split them out in separate blocks, basically. Why we separate them? Because HTTP header blocks, they have this header called date that changes every second. So because of that, if we take the whole thing as a single thing and store in IPFS, we won't be achieving the deduplication functionality. So that's why we split it and we say this area is changing, the rest of the thing might not change, so let's put it separately. So then we push these two blocks in IPFS, and IPFS gives us two hashes. We store those hashes in index entry, and here it is com.example.ipwayback or whatever URL it could be, and what time we observed that, what is the header hash of the header, and hash of the payload. We preserve these two entries, and we create many more entries like this. So for entire WARC file, we have all these entries one by one, and these are like pretty printed, but actually these are one record per line is how it is stored in our WARC files. Sorry, CDXJ file, which is our index. So at replay time, you look for a URL, you find a date time that is suited to your need. We'll go and find in our index where that entry matches. We'll find the headers and payload references, fetch from the IPFS those two things, and then two blocks are combined, necessary changes are made, and then it is replayed. So what you are seeing here is a replayed from the archive, and there is a nice little banner there that tells when it was archived. So here is another important thing that we had to do in order to replay effectively, is to block any resources that are being loaded from live sites. And for that, I've created a service worker called Reconstructive, which is installed in user's browser, and kind of traps every single outgoing request and make sure they don't live leak, they come from the archive. And the same service worker also injects that little banner that you saw. So this is the whole process. We take the WARC files, index it, and the content are pushed into IPFS store. Necessary references are pushed into CDXJ files. And then at replay time, we look up into the CDXJ file, fetch content from IPFS store, combine them, and replay them. Now, what is next? How many minutes I'm left? Anyways, 5 minutes? All right. So current issues in what we have implemented. The content is now decentralized, but index is not. That's a problem. So you can only replay if you have that index available. And IPFS guarantees permanence, but not persistence. So someone still has to inject those hardware resources to store that data, and how, if one side goes away, how it can be replicated. And IPNS that is currently used, it uses DHT, which does not allow historical lookup of mapping from URL to hashes. So that's another problem. So we want to solve these problems. So first, persistence problem. I think memory organizations like Web Archives and some other funded libraries, they can provide hardware. Tools like Query, Filecoin, IPFS Cluster, IPFS Sync, all these tools can help to synchronize data and make sure things are available in redundant locations. So talking about the IPNS problem, right now, the simplest approach right now is like you have a URL, it maps to an IPFS hash, and so on. When you update a URL's hash, the content is changed, the hash is modified, now the previous one gone. You have no record what was the previous mapping. So we want a system that allows, given a URI, it gives us latest hash. Given a URI and date time, it gives us a historical record of mapping. Given a URI only, it also provides us all the historical records, all the hashes basically, along with the date times. So for this in mind, I've created a document called IPNS plus blockchain plus Memento, and I call it like IPNS blockchain. Memento protocol can be put on top so that we can do query the same way we do in archives. This is not the only way. There are more ways to do this. One option would be to keep using DHTs for live mapping, but all the historical records can be pushed in a blockchain or something, or there could be other ways. So I'm open to ideas and other implementations for that. The third thing that we want is the lazy relationship evaluation. So for example, so if we do whatever we suggested so far, if we do that far, what we'll be able to achieve is going forward, all the web history will be preserved. But what about the stuff that people captured before? For that, we want something like this. Like we create a dummy block somewhere where say, this is my name is space, under that I'm about, and then say CNN.com. And that is my reference block for all the CNN.com captures. And every memento that we capture, we can point to and establish a relationship. I'm a memento of that particular meta block. And then we want a mechanism to query back saying, give me all the mementos that belong to this, basically. That would be awesome if we can do that. I don't know if IPLD can solve this problem, but if it can, that will be awesome. So we had a little bit of evaluation. So we tried to put data into IPFS system in comparison to plain Unix file system. It has roughly 10% overhead that were because block metadata and all. And also, timing to push into the system was really slow. But that problem has been fixed, I guess. We did not evaluate that again. So when we try to replay using the and compare it with the state-of-the-art replay system like 2 minutes, all right, Wayback, it was able to serve like 600 requests in 5.2 seconds, but our system took like 222 seconds. That's not acceptable. So we tried to use some threading so that we can fetch the two objects in parallel, but we failed miserably. And our story is in that link that we have provided there. There is some work need to be done there. So future work, we want to evaluate the time to push into IPFS again with a bigger data set. We want to evaluate deduplication, but this is a tricky thing because deduplication, the more content you add, the better performance you will get. So when you stop, I can prove like I'm 100% efficient or 5,000% efficient as many duplicates I push into the system. So I need to select some data set carefully for that. And we want to implement an index-free system so that we don't have to rely on index, and we can query into the system directly in IPFS, IPNS, or IPLD, whatever it is, basically. With that, I'll conclude. So this was a proof of concept tool developed in a hackathon. We tried to enhance it. There is more work going on. Actually, if it is implemented properly, we won't have this problem of like who will archive these archives when they are gone. And a truly decentralized archiving system is yet to be done. So thank you so much for listening. And I could have given a little demo, but my computer is not connected, so I'm sorry about that. Any questions? No questions? Yes. All right.